Good morning, my dear students. Today I am going to discuss the next topic under the haloalkanes and haloarenes. Today I will discuss haloarenes and Criconaut reagent, which is common in both haloalkane and haloalkane, which is a good synthetic reagent. We can synthesize a number of organic compounds from that. I am Dr.R.G, Professor of Chemistry, who is taking class for you. Under the haloalkanes or the haloarenes or aryl halides, kindly follow, there are actually, we have two types. A haloarene specific example, chlorobenzene, kindly follow, or another name, aryl halides. Specific example is chlorobenzene. There is also another compound called R-alkyl halides. Kindly follow, R-alkyl halides. This is called benzyl chloride. Benzyl chloride. This is R-alkyl halide, specifically chloride. So we are concentrating only the haloarenes. So specific example, chlorobenzene. Kindly follow. So let me take chlorobenzene. Methods of preparation. We can prepare chlorobenzene from a number of compounds. So first let us see different methods of preparation of the chlorobenzene. Aryl chlorides and aryl bromides are generally prepared from arenes. Kindly follow, arenes, nothing but benzene. So we are calling it as benzene, or the higher member will say toluene, like that. So here in this case, chlorobenzene we can prepare from benzene. So by the action of chlorine or bromine in presence of catalysts such as ferric chloride or ferric bromide. So commonly we are preparing chlorobenzene or bromobenzene. So in this case I am giving a specific example. From benzene I am preparing chlorobenzene by the action of chlorine in presence of catalyst ferric chloride. Please follow. Suppose if we want to get bromobenzene, I will use bromine in presence of ferric bromide. That is the only difference. So this is one of the method of preparation of the corresponding benzene. Kindly follow. Now, same way, in the case of bromine I told you, so take benzene, bromine and ferric bromide, you will get bromobenzene and HBr. So here important information you want to know, kindly follow. Fluoro and iodo compound cannot be prepared by this method. Please note. Question can be asked. Only chlorine and bromine can be substituted, undergo this reaction. Iodo compound can be prepared with iodine in presence of nitric acid and iodic acid. Kindly follow. So this method is suitable only to prepare chlorobenzene and bromobenzene. Kindly follow. The next second method, from benzene diazonium chloride we can prepare. Chlorobenzene can be prepared from benzene diazonium chloride. The name of this reaction is Sandmeyer reaction. Kindly memorize what is Sandmeyer reaction. One among the following reaction is called Sandmeyer reaction. Question can be asked. Chlorobenzene can be prepared by the decomposition of benzene diazonium chloride in presence of HCl and copper 1 chloride, that is cuprous chloride. So this is benzene diazonium chloride. HCl in presence of cuprous chloride converted into chlorobenzene and nitrogen gas is getting escaped. See, this nitrogen gas, it is going out, leaving the chlorine attached to benzene ring, forming chlorobenzene. This is the famous reaction, Sandmeyer reaction. Kindly follow. The third method, which is industrial method. This method is called a Rastic process. Please memorize this, Rastic process. Chlorobenzene is produced industrially by passing a mixture of benzene vapor, air and hydrogen chloride over copper 1 chloride catalyst. Kindly follow. So chlorobenzene is produced industrially by passing a mixture of benzene vapor, air and hydrogen chloride over a copper 1 chloride catalyst. That process is called Rastic process. So benzene we are treating with HCl. Kindly follow. In presence of catalyst cuprous chloride, copper 1 chloride and atmospheric oxygen. Kindly, if that is air, from the air it is taking, we are getting chlorobenzene and water. This is the industrial method. Coming for properties as usual, first let me see the physical property. Chlorobenzene is a colorless, pleasant smelling liquid. It is insoluble in water. This is the characteristic property of physical property. So let me come back. Chemical properties. If you take chlorobenzene, kindly follow my dear students. So what is happening here? So there is chlorine atom attached to benzene ring. This is chlorobenzene. So we are now going to classify these into two types. One is reaction due to benzene ring alone, substitution, and reaction due to chlorine atom alone. So it has an aromatic ring and chlorine atom directly bonded to the ring. Kindly follow, this is the way it is there. So based on this, I can classify the reaction into two types. Reactions involving aromatic ring. So reactions involving aromatic ring I am classifying as one type. Another type, reaction involving halogen atom. Please follow. So first let me take reactions involving aromatic ring. So under the aromatic ring, the aromatic electrophilic substitution reaction. Please recollect, my dear students. Under the basic concept of organic chemistry, I have discussed the reactions and mechanism. That is the one unit I have discussed. Under this, I informed you there is different types of mechanism, and I have informed you always generally aromatic compounds undergo electrophilic substitution, whereas aliphatic molecules undergo nucleophilic substitutions. The reason is because in aromatic ring there are 3 bi-bond, so 6 pi electron is revolving, so having a negative charge, so it will always, the electrophile can be easily attaching this benzene ring. First forming a bicomplex, then it is converted into sigma complex. This is the general reaction I have informed you. So now let me discuss what are the important reactions in aromatic ring. Chlorobenzene undergoes typical aromatic electrophilic substitution reactions like alkylation, acylation, halogenation, nitration, and sulfonation. Kindly follow. So kindly remember, my dear students, this is the 5 important reactions we are going to discuss in all types of organic compound. So, the entire reaction mechanism I have already discussed under the basic concept of organic chemistry. That is, depending upon the nature of the groups attached, so it may be the incoming electrophile will go to ortho and para or meta. That's called ortho-para orienting group or electron releasing group. The meta-orienting group or electron attracting groups I have discussed. So under this only we are going to discuss alkylation, acylation, halogenation, nitration, sulfonation. Why I am giving importance? Because these all 5 reactions we are going to discuss in alcohol, aromatic alcohol, phenol, the corresponding nitro compound, nitrobenzene, and aniline. So all cyanide, everything, this is the reaction taking place. Kindly follow. First let me take alkylation. So this is actually, we will call it as, kindly follow. Now generally we will call it as Friedel-Graf reaction. Friedel, we have already Friedel-Graf alkylation. This we have discussed already under the hydrocarbon. Kindly follow. So here what is happening here? So we are taking chlorobenzene, we are taking methyl chloride in presence of anhydrous aluminum chloride. So chlorine, it is the electron releasing group. So what will happen in electron releasing group? What will happen? Kindly follow. Please understand this. Whenever you write mechanism, we should not put round there. It is the conventional method. You will put a double bond. So here is a chlorine. So just see, if you suppose here double bond is coming, left side is nearer. Sometimes you will write right side. So what this is electron releasing. So what will happen now? It will push electron here. It will push electron here. It will push electron here. So that means electron is releasing towards the ring. That means the ring is getting activated. Please follow. Activate the ring. The groups which are releasing, all releasing groups are activating the ring. Kindly follow. That's why they are undergoing easily electrophilic substitution. So this is minus, here plus, minus. Kindly follow. So 2 ortho positions. So numbering I will give if you want. 1, 2, 3, 4, 5, 6. So 2 and 6, kindly follow, ortho. 3 and 5, meta. 4, that is para. The one it is called ipso. Kindly note, my dear student, it is not given in your book. In your book it will not be given. Ipso carbon means where the substituent is present, carbon is ipso carbon. Kindly follow. So what will happen because of this? When electrophile means methyl chloride, actually when it is reacting with anhydrous aluminum chloride, converted into the methyl plus. So this electrophile, that is the aluminum chloride taking this chlorine, AlClO4 minus it become. So CH3 plus, now it will attack both ortho and para. Kindly follow. Because negative is there, only in negative position it will go. As I already told you, it will first form bicomplex, attach the central ring bicomplex, then it will be converted into sigma complex. Kindly follow. So here it is ortho, a mixture of two products, ortho and another is para with respect to chlorine. Kindly follow. This is, if you want to name this is 2-methyl 1-chlorobenzene. This is 4-methyl, that is 1-chloro-4-methyl benzene. Or simply we'll say, this is the ortho products, this is para product. Kindly follow. With respect to chlorine, CH3 ortho, with respect to chlorine, CH3 para. So this is the most important reaction. So if it is undergoing alkylation, it is producing a mixture of two products. Suppose if it is acylation, the only difference is instead of methyl chloride, we are using acetyl chloride. Not necessarily acetyl chloride, any acetyl chloride you can use, general. So what will happen here? In this case, this will break in the form of ROC plus as an electrophilic reagent. So, in this case, acetyl chloride, CH3CO plus is attacking. This again, CH3CO plus again is the ortho-para orienting group. So, going here, ortho and para. So, this I'll call it as, so this is the main compound, COCH3 in the main compound. There are two functional groups here. So automatically we have to go according to the type 2 compounds, type 3 compounds, more than one functional group. We have to follow the seniority. Whatever group in the top list, we have to give name. So this is acetophenone. So this is 2-chloroacetophenone. Please follow. So ortho product. This is 4-chloroacetophenone. Para product. This is ortho, this is para. Again, obeying this electrophilic substitution reactions. Under halogenation, specifically I am taking chlorine here. So, chlorobenzene reacts with chlorine in presence of iron. So, we are getting this ortho dichlorobenzene, para dichlorobenzene. Or 1,2-dichlorobenzene, 1,4-dichlorobenzene. So again, ortho and para. Kindly follow. Now, coming for nitration. What is nitration? So, NO2 group plus group will attack the chlorobenzene ring. Kindly follow as usual. We know this is the double bond here, chlorine. So this is normally minus because of this. Minus, kindly follow, plus, minus. So 2 ortho and para portion minus. So what will happen when you treat with nitric acid and sulfuric acid? Kindly follow. Nitric acid, this mechanism I have already discussed. Kindly follow. Plus 2 moles of HOSO3H. So, what is happening here? Kindly follow. This sulfuric acid is acting as an acid. This is as a base. So, it is cleaved like this. Kindly follow. So, what will happen now? Automatically in the product we are getting NO2 plus one of these species. This is the initial step. Then H2O plus, then 2HSO4 minus. This is the step 1 in the mechanism if you want to write. So among these two, this is the powerful electrophilic reagent compared to H2O. So it will easily attack the chlorobenzene. As usual, it will attack in the ortho as well as para. Kindly follow. So it is orthochloronitrobenzene, metachloronitrobenzene. Orthochloro and metachloronitrobenzene. A mixture of products it is formed. Finally, sulfonation. In the sulfonation, chlorobenzene reacts with consulfuric acid to produce orthochlorosulfonic acid, benzene sulfonic acid, parachlorobenzene sulfonic acid. As usual, here I want to mention how this will act as, kindly follow. This is sulfuric acid. So what will happen now? This is going like this, kindly follow. This is single bond. So OH. So H and OH becoming water. We are getting a neutral SO3 plus OH, the water molecule, it is formed. So one important information I want to convey here. We have seen 5 reactions, electrophilic substitution reaction, that is alkylation, acylation, halogenation, nitration. In all the 4 cases, electrophil is a positive species, whereas here it is the neutral SO3 is attacking. Please follow. Neutral, this question can be asked. One among the following is a neutral electrophil. So SO3 is a neutral electrophil. As usual, it is the attacking here benzene ring into SO3H and also para position SO3H. This is orthochlorobenzene sulfonic acid, parachlorobenzene sulfonic acid. Kindly follow. Now, the another important thing, just I want to give here, the chlorobenzene, additional to the 5 reaction, another important reaction, formation of DDT. What is the DDT? It is para dash dichloro diphenyl trichloroether. This is the name for DDT. Para dash dichloro diphenyl trichloroether. Just see 2 molecules of chlorobenzene reacts with 1 mole of CCl3CHO. This is called chloral. That is chloral, we will call it as trichloroacetaldehyde. In presence of consulfuric acid, so it undergoes condensation reaction to produce this product. So what is this? So this is, we will call it as para. This is para means this I will call it as para dash. Para dash dichloro diphenyl. Kindly follow diphenyl trichloro 2 carbon atom ether. Kindly follow. That is called DDT. Normally this question will be asked. Kindly follow. Okay. So far what we have discussed, that is reaction taking place due to aromatic ring. So now I will discuss reactions involving the halogen atom. Only the halogen atom. Simply substitution reaction with chlorine. Okay. Right. So this simply I will call it as nucleophilic aromatic substitution. I told you already, generally electrophilic substitution is common in aromatic ring due to the 3 double bonds. But under drastic condition, high temperature, high pressure, suitable catalyst, sometimes nucleophilic aromatic substitution also takes place. So we are going to see. Kindly follow. Due to the tendency of halogen atom to share its lone pair of electrons with benzene ring, it acquires a double bond character. Please follow. How you can understand this? Kindly follow. This is the benzene ring. Kindly follow. So we are having chlorine. We know what is the electronic configuration of chlorine. It is 3s to 3p5. The 7 electron in the outermost. So here 6. So one electron mutually shared with the ring. So it is forming a covalent bond. So it is attached here. It is an electron releasing group, I told you already, when it is attached to benzene ring. What will happen now? This lone pair is giving here. It is moving like this. Kindly follow. So what I can write this ring, kindly follow. The benzene ring will be in the form of the double bond Cl plus. Kindly follow. Because now only 2 electron pair is there. Instead of 3, the lone pair is going inside the ring. Kindly follow. So now we can see a double bond character. So due to tendency of halogen atom to share its lone pair of electron with benzene ring, it acquires double bond character. Hence, nucleophilic substitution of chlorine atom can take place under vigorous condition. That's why under vigorous condition only it will take place. Please follow. So because of this double bond character only, this releasing character also, that it is actually, if you go for aliphatic compound, halogen atom is an electron attracting group. Whereas in this case it is acting as an electron releasing group, that too only in the last one. Kindly follow. Weak electronic releasing group. Okay. Now let me take the first one. Formation of benzene. That is called reduction. Removal of chlorine and the addition of hydrogen. The chlorine is substituted by hydrogen. That is, addition of hydrogen is called reduction. When treated with nickel aluminum alloy in the presence of sodium hydroxide, chlorobenzene undergoes reduction to produce benzene. So this we can even take for the hydrocarbon preparation. So chlorobenzene in presence of nickel aluminum alloy and sodium hydroxide undergo reduction to produce benzene and HCl. This is so the chlorine is substituted. Kindly follow. The second important reaction, a famous reaction, Woods-Fittig reaction. Woods-Fittig reaction. Formation of methyl benzene, ethyl benzene. So anything you can prepare by this. Here I have given ethyl benzene. Because I have taken ethyl chloride, the product is ethyl benzene. If I take methyl benzene, I will get methyl benzene or toluene. Kindly follow. So here I want to give one important information. Under the name of Woods-Fittig, so we have 3 types you have to memorize. One is Woods reaction, Woods-Fittig reaction. Another is Fittig reaction. What is the difference between this? So Woods reaction is only suitable for preparation of alkane containing even number of carbon atom. Simple example, methyl bromide in presence of sodium in dry ether, you will get this Woods reaction. Ethane is suitable only for even number of carbon atoms. So ethane, butane, hexane, like that. Woods-Fittig means, kindly follow, both are aliphatic. Woods-Fittig means one part aromatic, another part aliphatic. Whereas Fittig means both molecules are aromatic. Kindly memorize this. Woods both are aliphatic. Woods-Fittig, one is aromatic, another is aliphatic. Fittig, both are aromatic. So here Woods-Fittig, kindly follow. Chlorobenzene on reaction with sodium and ethyl chloride in presence of ether produces ethyl benzene, sodium chloride. Suppose if I am using methyl chloride, kindly follow. So I will get here the correspondingly the toluene, methyl benzene I will get. That means so Cl is substituted by CH3CH2. Kindly follow. This is the Woods-Fittig reaction. Now, formation of biphenyl. As I already told you, phytic reaction. Both are aromatic. Two molecules of chlorobenzene in ether solution react with the sodium to give biphenyl. Always ether is the solvent we are using. In all phytic, the Woods reaction, Woods phytic. So two molecules of benzene, chlorobenzene, react with this. So it is removing this, we are getting biphenyl. Kindly follow. The most important name reaction, phytic reaction. Now, the next most important is formation of Criconaut reagent. This is the another most important. Kindly follow. Even in the aliphatic compound, also Criconaut reagent, it is formed. So, in this case, special case, chlorobenzene reaction with magnesium in presence of tetrahydrofuran, THF, tetrahydrofuran, to produce phenyl magnesium chloride, a Criconaut reagent, aromatic Criconaut reagent. Kindly follow. So, this can be useful for synthetic a number of organic compounds. So, this again Cl is substituted by magnesium chloride. Please follow. So, this is the most important Criconaut reagent. The next, another most important reaction is formation of phenol. That is called Dow's process. Please remember, very important. Dow's process. When chlorobenzene reacts with the sodium hydroxide at a high temperature, high pressure to produce phenol. So, chlorobenzene reacts with sodium hydroxide at 623 Kelvin and 300 atmosphere. Kindly see how much, very high, to produce phenol. Only at high temperature, this nucleophilic substitution takes place. Nucleophilic substitution takes place. So, we are getting phenol and sodium chloride. Kindly follow. And formation of aniline with chlorobenzene. Chlorobenzene reacts with ammonia as usual at high temperature, high pressure to produce aniline and ammonium chloride. Aniline nothing but aminobenzene. Kindly followed. The temperature 523 Kelvin, pressure 50 atmosphere, we are getting aniline or 1-aminobenzene, aromatic compound. So, chlorine is substituted. Kindly follow. The next is formation of phenyl cyanide. Please follow. The chlorine is substituted by cyanide. So, chlorobenzene reacts with the copper cyanide at high temperature and high pressure to produce phenyl cyanide and copper 1 chloride. Please follow. What is the high temperature? 523 Kelvin. High pressure and the catalyst pyridine is used. So, we are getting phenyl cyanide. Kindly follow. And cuprous chloride. Copper 1 chloride. Please follow. So, coming for uses, kindly follow. It is used, one, for the manufacture of many compounds like phenol, nitrobenzene, etc., which are required for the manufacture of azo and sulfur dye. Number two, for the preparation of insecticide like DDT and benzene hexachloride. Benzene hexachloride. Kindly follow. DDT. DDT we have discussed, already told you, para-dash, dichloro, diphenyl, trichloroethane. Benzene hexachloride means, just see this is the benzene. Kindly follow. So what will happen here? Automatically this is forming HCl, and HCl. Kindly follow. In all the 6 carbon atom, so this chlorine is substituted. Benzene hexachloride. Kindly follow. So what will happen now? In this case, this hydrogen atom is substituted by chlorine, so there will be no hydrogen. So what will happen now in this case? That is formed benzene hexachloride. Kindly follow. Now, Criconaut reagent. So this is the next subunit. So we are going to discuss the Criconaut reagent. That is, organomagnesium halides are called Criconaut reagent. They are generally represented by RMgX. Specific example, methyl magnesium iodide, normally given in the form of ether solution. Kindly follow. So preparation, methyl magnesium iodide can be prepared by the action of methyl iodide on magnesium in suspended dry ether. All the reagents should be pure and dry completely. Please follow. When the reaction is completed, a clear solution of methyl magnesium iodide is obtained. This is used as such in all the reaction. It is used as such means in the form of ether solution. You have to use. So this is the reaction. CH3I plus Mg dry ether, CH3MgI. Please follow. This is the most important reaction. So, methyl magnesium iodide is the specific example I am giving. Now, I am going to discuss synthetic applications of methyl magnesium iodide. Methyl magnesium iodide can be used to synthesize a number of variety of organic compounds as follows. So, starting from alkane, alcohol, ether, aldehydes, ketones, carboxylic acid, carboxylic ester, cyanide, etc. So, any compound you can prepare in the laboratory, synthesis in the laboratory by using methyl magnesium iodide. So, let me go one by one. First one, preparation of alkane. Say for example, methane. I can prepare benzene, I can prepare ethane, I can prepare. Here I have shown you methane. Kindly follow. Methyl magnesium iodide undergoes double decomposition with water or alcohol to produce alkane. So when you treat, because it need only hydrogen. So what will happen now? This MgI taking this OH. So CH3H become methane. So MgOHI will form. So methane is produced. Same way, if we take alcohol, same way, this H will take correspondingly, this CH3, it is taking this H, producing methane, and correspondingly MOCH3I it is forming. Kindly follow. That means, here the reagent is providing a proton. So that the alkyl part or aryl part will combine with the hydrogen to form alkane. Very, very easy method of preparation. This is of the alkanes. So the next synthesis of alcohol. Kindly follow. Alcohol. So when you say alcohol, we have three types of alcohol. Primary alcohol, secondary alcohol, and tertiary alcohol. We will be discussing later on the preparation properties after this chapter. Anyhow, what is primary, what is secondary, what is tertiary, we have discussed already under the common name of the nomenclature. So anyhow, I will give a specific example. Primary means OH should be attached to only one carbon. Kindly follow CH2, 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 OH. This is primary butyl alcohol and this is secondary butyl alcohol and third one CH3, CH3, C, CH3, CH3, OH. So this is the tertiary butyl alcohol. Kindly follow. Primary, secondary, tertiary based on if any functional group attached here OH attached to a carbon which is further attached to only one carbon, primary. Here OH attached to one carbon, it is attached to two other carbon, it is secondary. Here OH attached to a carbon which is attached to three other carbon, tertiary. Please memorize, this is the way. So let me concentrate first, primary alcohol. Kindly follow, here I am going to use aldehydes and ketones we are going to use to form primary alcohol. My dear students, please memorize this one. So, if you use formaldehyde, you will get primary alcohol. Any other aldehyde other than formaldehyde, say for example acetaldehyde, it will give secondary. If you heat ketone, any ketone, it will give tertiary. So, the easy way you memorize this. Please follow. Formaldehyde gives primary alcohol with Criconaut reagent. Any other aldehyde other than formaldehyde gives secondary. Any ketone gives tertiary alcohol. This you have to memorize. Other will be easy. Kindly follow now. I want primary alcohol. So what I have to use? Formaldehyde. Methyl magnesium iodide undergoes addition reaction with formaldehyde to give addition product which on hydrolysis yield ethanol, primary alcohol. See the reaction. The first step, there is a double bond here. It will undergo like this. So this is undergoing like this. Kindly follow. CH3 minus, please follow, because it is organometallic compound. Metal is positive and CH3 minus. So minus will add to the positive carbon. So we are getting this intermediate. Kindly follow. This is the intermediate it is forming. Kindly follow. And this intermediate, in the second step, undergoes hydrolysis in presence of acid medium. We are getting this ethyl alcohol. That is CH3, CH2, OH. What way? So here it is cleaved. What way? Water is added. H and here is H. Kindly follow. So we are getting CH3, CH2, OH, primary alcohol. So formaldehyde gives primary alcohol. It is only two-step process. Then coming for secondary alcohol, I told you already, any aldehyde other than formaldehyde, here acetaldehyde. Methyl magnesium iodide undergoes addition reaction with CH3CHO to give addition product which on hydrolysis yield isopropyl alcohol, that is secondary alcohol. Kindly follow. See, methyl magnesium iodide reacts with acetaldehyde as usual. This is undergoing, add this intermediate, and this intermediate undergoes reactions as usual, producing H here. So CH3CH3 HOS. This is the compound. This is isopropyl alcohol. I can write this way, then you can easily understand. This is secondary alcohol. Isopropyl alcohol is called secondary alcohol. Please follow. So we are using normal, iso and neo. That way we are giving common name. Or if you want to give the corresponding IUPAC name, it is 2-propanol. It is 2-propanol. Kindly follow. That is secondary. Coming for tertiary, kindly follow. Preparation of tertiary alcohol. Methyl magnesium iodide undergoes addition reaction with acetone to give addition product which on hydrolysis yield tertiary alcohol, tertiary butyl alcohol in this case. So as usual, the double bond here is cleaved. This is again cleaved like this. So adduct is forming here. That is an intermediate. So this intermediate on hydrolysis as usual giving, that is the OHH. Kindly follow. This is the tertiary butyl alcohol. Tertiary butyl alcohol and MgOHI always is the common product. Please follow. So in the case of alcohol preparation, we can prepare any primary, any secondary, any tertiary alcohol we can prepare. The same way, any higher number of ethers can be prepared using Criconaut reagent from the lower member. Kindly follow. How? Example, kindly follow. Methyl magnesium iodide undergoes double decomposition with methoxymethyl iodide. Kindly follow. This is called methoxymethyl iodide. Common name. That means one of the hydrogen atom is substituted by iodine. So, when you treat with methyl magnesium iodide, a double decomposition means the correspondingly CH3 is substituted, I will come out. So, it is producing methoxyethane or methyl, the ether or 1-methoxyethane, IUPAC name. Ethyl methyl ether, a common name. It's a higher member. So, ether can be prepared. Aldehydes. So, using this Criconaut reagent is very, very important. Aldehyde also we have. For aldehyde, what we need is, we need this group. This is the aldehyde group. Kindly follow. This is the aldehyde group. So, what you have to use? You have to take the reagent containing this. What is the reagent? Just see here. Ethyl formate. So, any formate you can take. Kindly follow. Any formate. You can take methyl formate, ethyl formate, propyl, anything. When you treat with the Criconaut reagent, you are getting the corresponding intermediate for the producing aldehyde. Kindly see here. Methyl magnesium iodide undergoes addition reaction with ethyl formate. It is coming from formic acid and ethyl alcohol. To give addition product, this is the addition product. What is the undergoing addition? Kindly follow. This, the double bond is here. So, as usual, this is undergoing here. So, CH3 added is carbon, then Mgi plus is added to O minus. So, from this intermediate, now undergo hydrolysis. So, here hydrolysis means, kindly follow, here OH and H will be there. Kindly follow. So, what will happen now in this case? Automatically, you can think of here, and when it is undergoing hydrolysis, so this is also going out. Kindly follow. OC2H5 is also going out. Here, now in this case, just like in other cases, it's not simply undergo hydrolysis, but it is undergoing additionally the ethoxy group also going away. Let me show you how it is formed. So, this going out here, this is going out here in presence of water and hydrolysis. So, what will happen because of this? So, CH3C double bond OH, that is acetaldehyde, and magnesium, ethoxy and iodide we are getting. Kindly follow. In this case, a slight modification from other steps of the other compound. Only in the case of the preparation of acetaldehyde, it is different. So, because of the formate, that ethoxy is going out in the form of the correspondingly with Criconaut reagent Mg ethoxy I. So, we are getting acetaldehyde. Now, preparation of ketones. Now, ketone as usual, we need only C double bond O group. Kindly follow. It may be R I can put, or may be alkyl part or aryl part. It may be anything. So this reagent you have to take correspondingly in the form of halide. Please follow. So if it is the aliphatic, acetyl chloride you take. Otherwise, benzyl chloride we can take. Kindly you can see here I am taking an example. Methyl iodide undergoes addition reaction with acetyl chloride. This is the acetyl chloride common name. To give addition product with methyl magnesium iodide, Criconaut reagent, forming the intermediate, which on hydrolysis yield acetone, a ketone. Acetone, the two 2-propanone. Kindly follow. So what will happen now? After this intermediate, again it is the same way it is cleaved. Kindly follow. So what is coming out now? Acetone we are getting, and MgClI we are getting out. So we are getting acetone. Suppose if I want to get corresponding acetophenone, instead of none I will take C6H5MgI I will take. Kindly follow. If I take C6H5MgI, automatically I will get acetophenone. So any ketone we can prepare. The next important is preparation of carboxylic acid. The very interesting here. So carbon dioxide is the best reagent to prepare for carboxylic acid group. Methyl magnesium iodide undergoes addition reaction with carbon dioxide to give addition product, which on hydrolysis yield acetic acid. What way it undergo addition? Kindly follow. It is undergo addition like this. What will happen now? So, okay, let me show you here. According to this here, it is undergoing the addition here like this. So, this is going out in the form of, as usual, minus. So, automatically minus, we added the carbon atom, the CH3. Then O, it is added MgI, intermediate. So, this intermediate, now second step, undergo again hydrolysis, producing corresponding acetic acid, OH and H. Kindly follow. Acetic acid and MgOHI. So we are getting acetic acid. So not necessarily we are getting acetic acid alone. We can get any member. Suppose we want propionic acid, use ethyl magnesium iodide. Ethyl magnesium iodide. Suppose you want to get the benzoic acid, use phenyl magnesium iodide. So any acid we can synthesize. Kindly follow. And ester, preparation of ester. Methyl magnesium iodide undergoes addition reaction with ethyl chloroformate. Please memorize. When you use ethyl formate, we are getting aldehyde, formaldehyde. Please follow. That is aldehyde group. Aldehydes can be prepared. But if you use ethyl chloroformate, it will give ester to give you additional product which an hydrolysis yield ethyl acetate. See here, this is the ethyl chloroformate. This is the formate. Instead of chlorine, H is there, it is called the ethyl formate. So since it is hydrogen is replaced by chlorine, it is called ethyl chloroformate. Undergoes addition reaction with methyl magnesium iodide. What way? As usual, you cleave down. So methyl group attached here and MgI is attached to O, intermediate is formed. So now what will happen now? It is undergo hydrolysis. What way? So this is now going out in the form of, kindly follow, the MgI, kindly follow, and Cl minus, kindly follow. So it is coming now, ethyl formate we are getting. And we are getting now magnesium chloride I, MgClI we are getting. So what is the product now? Ethyl acetate is the ester of acetic acid. So any ester you can prepare. Only thing is what you have to use in that case, and that purely depends upon the Criconaut reagent, nature of Criconaut reagent. If you use methyl, it is the corresponding acetic acid. Only from carbon dioxide COO group is coming. So if you use CH3 corresponding the ethyl acetate. If you use ethyl chloride here, it's a propanate. Like that you can. Even aromatic ester you can prepare by this method. The cyanide, preparation of cyanide is another important synthetic applications. Methyl magnesium iodide undergoes double decomposition with cyanogen chloride to produce methyl cyanide. Please follow methyl magnesium iodides. It is the cyanogen chloride. So simply it is now taking this chloride and CH3C and is called double decomposition reaction producing methyl cyanide and magnesium chloride iodide. So this way we can prepare, synthesize methyl cyanide. Students, I have come to the conclusion. Thank you very much for the kind cooperation given so far. Students who are coming for the first time to see my channel, Neat Chemistry by Dr.R.G channel in YouTube. So if you are the first time you are seeing, kindly click like and click subscribe to motivate me so that I can, with more interest, I will continue this channel. And also, after finishing the entire chapter, because I want to give one information, I started just 1 month ago this channel in order to help poor students of India. So as a chemist, I am a chemistry professor, I want to give the basic and theoretical ideas without any doubts. They want to study chemistry. Normally students will afraid of physics, chemistry and maths. So here my aim is to not to start this one. So even to help poor students who need not go to chemistry tuition. If you see our YouTube, it is enough. You will get 100 out of 100 marks. If you even need chemistry, you can get 180 out of 180 marks. Because after finishing this syllabus, I am going to discuss questions from 20 years of question paper from IIT, Ames, AFMC, AIPMT, MSET Andhra, etc. Kindly follow. So, in order to additional information is, under the basic and the first unit, I have taken 8th standard, 9th standard and 10th standard chapter also I included according to the nature of positions, I included under the basic concept. Actually, in our book, only 16 pages are there in the basic concept, but I have given 17 lesson hours discussion I have given. Please follow. So even this is suitable for 8th student, 9th student, 10th student, 11th, 12th and 12th completed students also who are going to write NEET entrance examination. So for students who are waiting for NEET entrance examination for the coming academic year, so this is, I want to give one information. We are running Vetri Coaching Center in Pondicherry for the last 21 years. And we have a lot of achievement in these 20 years. One or two, if you go, we have our website, Vetri.us, Vetri Namade in Tamil. It is if you go for home page, you can see the inaugural and all our achievements with the photograph, every year, the students list, everything is given. So let me give two important evidences for this achievement. One is, every year minimum 10 to 20 students are joining in JIPMER Medical College. 150 to 200 students are joining in other medical colleges. Few students are joining every year in IIT. Hundreds of students are joining in other engineering college. This is our first achievement. The second achievement, in 2003, our student R. Srinivasa Raghavan got All India first rank in JIPMER entrance examination. At that time, NEET common entrance examination was not there. So this is our achievement. Now, I want to give some information regarding Vetri.us. Vetri.us has a very important feature, 3 important features, which is not available in any other online coaching in India. Kindly compare and you can see yourself. Because free versions are given in all cases, including Vetri.us, we have free version. NEET free. It is given. You go freely, register and see also. One of the important features is we have given 200 video lesson. 200 unit test. Please follow. 200 video lessons were taken by the senior most professor with a PhD degree and 20 to 30 years of experience in IIT and medical coaching also BSc, teaching for BSc, MSc, MPhil and PhD students. So only those professors are handled the classes. And when you are doing the video lesson, there is the facilities provided to you. You can stop video, you can take notes, and then again press the video, it will move. So any number of times you can see. The another important thing, 200 unit test. As per the, based on the NEET chemistry, so we are giving 45 questions in each unit. So for example, in this case, haloalkane and haloarenes. So there will be 2 tests. Each unit will have 2 tests. So test 1, test 2. Here 45, here 45. So that totally you can write 2 tests you can write under this to improve your quality. Kindly follow. All these questions we have framed for the unit test by taking 20 years of question papers of original IIT, AIMS, AFMC, AIPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu and Pondicherry previous year question papers. So all question papers are original previously year asked questions. What is the interest information we are getting from this? So for the last 6 years we are seeing from the NEET entrance examination, we observed 75 to 80 questions. Same questions are repeated. Please follow. Same, without any change. Same questions are repeated. If you want to verify, take any question paper with you and go inside of our website and compare. You can see, understand that minimum 75 to 80 questions you will get. Put a tick mark in your question paper, then count, you will get automatically 75 to 80. That means 20 doctors is giving 320 marks to you. And if you are a good student, you will get easily 300 plus. So you will get easily 600 to 700 marks out of 720. You will become all India rank. You will get anywhere you join. You can join JIPMER, you can join AIMS or Vellore, anywhere you want. Even a dull student, they can get minimum 500 marks if you attend all the 200 tests in 20 daughters. Because the training process are such a way that which is not available in other online. Let me explain the test. How test is conducted online by the self-assessment, you can do it yourself. So if you go for open our site, Vetidatas, the Chrome you can click, it will go there. And if you are a member, if you want to register a member, you have to pay 10,000 rupees per year and you have to join. Otherwise, you can see the free version is given there. You can go to the NEET free and click, register yourself and then log in. Then go for the see the free end. So in the free itself, we are giving the same model we have given. So here what is happened? So suppose you want to see the lesson, click lesson, unit-wise lessons will be given. Each unit will be having 3 or 4 lessons depending upon the weightage. And if you click the test, automatically you will have it will come for the unit-wise. Suppose in this case, haloalkane, if you click now, your window will open. In the window, it will ask you, that is, first it will be coming now, it will ask, this unit contains 45 questions, 45 minutes will be allotted, each question carries 4 marks, for correct answer 4 marks awarded, wrong answer -1, so are you ready? It will ask. If you say yes, click OK, immediately window will open, another window. The window now, you can see the question number 1. See the question. Option A, option B, option C, option D, you can see. And there are 3 other menus are there. Kindly follow. Below there is, kindly follow, there is the question number 1 to 45 number will be there in yellow color. Kindly follow. So if you click attempt, window will open and you can see that. Then if you click OK, then there will be clock will run here. Clock will run here 45 minutes. Then what are the 3 menus here? left side reverse, this is complete, this is next. Kindly follow. What is the idea here it is? What is the idea here it is? By using next, you can go for the next question, second, third, fourth, like that. If you use reverse, you can reverse. Only after completing all, you can click complete, you will get the marks. You can get our software, it is will give your entire marks. Kindly follow. Here, the another important option we are given here below 1 to 45 and the clock also running there. 1 to 45 questions will be in yellow color. Suppose you are seeing the question number 1 and if you feel A is the correct answer, if you click immediately, the number 1 which was in yellow color changing to green color. Number 2 will become blue color. All other questions will be yellow color. Suppose after attending some 20 questions, if you see below, all the 20 questions will be in green color, 21 will be yellow, the blue color, all the other will be yellow. So it easily you can assess what are the questions you have attended, what are the questions not attended. This facility is not available in any other online coaching. Kindly follow. Any other online coaching. So that means you can, at any time you can see, or even before completion, you can see which any question you have omitted, you can see from the yellow color, you can identify. Please follow. After completing, you press complete. Immediately, what will happen now? Another window will open. What will happen now? You will get marks. 160 out of 180. It is indicating your mark. Kindly follow. So that means you have lost to 20 marks. So where you have done mistake, you want to see, you want to assess yourself. So we have given provision which is not given in any other online leading coaching center. Please follow. That is available only in Vetty.us. What is that? There is a called review menu. Next to the mark, there is a menu called review. So if you click review, your window will open. You can see question 1. Question 1, you can see option A, option B, option C, option D, and the correct answer in yellow color. And below there is video solution. Video solution. Please follow. Video solution is provided only in Vetty.us. All other online leading coaching, if you go, they will give only, so they will say solution, but they will give only one word or one line. Will be typed matter, will be given. But here not like that. Another interesting information, since you have clicked A when you are attending test, so that your question will be in now blue color. Please follow. Your answer will be in blue color. Correct answer will be yellow color. You compare these two. If the answers are correct, your answer is correct. If answer is not coinciding, blue and yellow is not coinciding, your question is wrong. So you can assess yourself whether you are right or wrong. And also the provisions are provided below. There is a video solution. Each and every question, you click the video and see the video. That video will run nearly 10 to 15 minutes it will run. Please follow. It is just like your classroom. Professor will be standing in front of a board. That is professors with the doctorate degree and 20 to 30 years of experience in coaching of medical and IIT coaching. So what will happen now here? They will read the question first, read the options, then they will tell the basic idea behind what topic this is asked, what subtopic this question is asked, and what are the definitions, what is the formula you have used in the case of problem, and any differences, a tabular column, any diagram required diagram, everything will be given in the form of slide. Kindly follow. As in the case of video lesson, the video solution also you can stop and take notes. So this is the very, very important option which is not given in other online coaching. So even a very dull student can easily understand the questions. Please follow. That is the most important regarding for our need daughters. So I told you at the beginning, we are low cost, only 10,000 rupees we are collecting per year for 4 subject. Per year for 4 subject. So that, how to pay? Pay 10,000 rupees in the name of Santi, Director of Veterinary Coaching Center, Indian Bank. Account number 7127194771. IFC code IDB 000P134. Any query or of doubt, if you want to contact me, my cell number 989417645. This, which is also the WhatsApp number also. Kindly follow. So I hope I come to the conclusion. Thank you very much for you. See you again in my next topic. Bye bye.